Welcome to EDU World Space.
So we want to demonstrate when two lenses are close enough that the distance between them can pretty much be neglected, that we can treat those two lenses combined as they were one lens, and that the total of the focal length of those combined lenses is going to be related to this equation, which represents 1 over the total of the focal length is equal to the sum of 1 over the focal length of the first lens plus 1 over the focal length of the second lens, which in the terminology of the problem, F effective or FEFF is F total. So let's first start off with how the light ray will be affected when it hits the first lens, in which it would have, if not for the other lens, bent at a certain direction down, which if we send our second ray straight through this system, assuming it can be treated like a compound lens, we would have the image form here from lens 1. We would also have that the distance to the image is Q1 and to the object is P1. So let's go ahead and write out the lens equation as 1 over P1 plus 1 over Q1 is equal to 1 over F1. And we could have stopped there if it was not for the second lens bending the light further the moment the ray intersected the second lens. And so the actual light path is different, in which you have the actual image form right here, which we'll name IT for I total. And it's going to have a position. And let's go ahead and label this Q total. T for total. Okay, let's start writing out the second lens equation for the second lens, in which we have 1 over, we're going to introduce in a moment, and 1 over Q total is equal to 1 over the second focal length. So what do we put right here? Well, that's when we notice that we use the image formed from the first lens for this position. So let's go ahead and place that in right here, which is going to be Q1. But now we have to notice something regarding signs, and that is Q1 is on the right hand side of these compound lenses, but we set up our terminology for the position of the object is positive on the left hand side of these compounding lenses. So in this case, for the second equation, Q1 is actually negative. So now we can actually add these two equations together. And what do we get when we combine these? We get 1 over P1. These two terms cancel out, and we are left with 1 over Q total equals 1 over F1 plus 1 over F2. Something you notice here is the left-hand side of this equation is really defining the total effect of both these lenses combined. The light ray starts at the object O at position P1, and it forms an image at position QT. So this, in the end, is really equal to 1 over F total. And thus we are left with one over F1 plus 1 over F2 is equal to 1 over F total.